Hello, class. Today we are going to look at areas of circles and sectors. All right, so we're going to start with the area of a circle, and this should be pretty much review because you've been doing this for a couple of years, right? Area of a circle is pi r squared, where r is the radius of the circle, right? And so we just take the radius, we square it, we multiply it by pi, which is approximately 3.14, and that'll give us our area. Now, we will not be using 3.14. We will be using the pi button on our calculator. Just about every calculator has one. On the TI-84, it's right there in blue, so second pi. All right, so that's what we will be using. And so let's just do a couple of these, jump right in. So example 1, find each indicated measure. So we've got part A and B. So for part A, we're going to find the area of a circle with a radius of 2.5 centimeters. Well, that's not too bad. We just take the formula, area equals pi times r squared. The radius is 2.5, so area equals pi times 2.5 squared. And we don't know what that is. We just take a calculator, 2.5 squared, which is 6.25, 6 1/4. So the area is 6.25 pi. That is the exact area, 6.25 pi. And if the question asks for the exact value of the area, this is what it wants. Okay, leave that pi there at the end. Save it for the very last thing that you do because pi is dessert. It goes at the end. Right? Dessert goes last. Now we want this in decimals, so we're going to take this 6.25 and multiply it by pi, which gives us approximately 19.63. All right, so the area is approximately 19.63 centimeters, and it is area, so squared. All right. Area. Okay, so next thing we're looking for. The diameter of a circle with an area of 113.1 square centimeters. Okay, so let's see here. Don't have diameter, but we can find area. We know stuff about area. So area, again, is pi times r squared. So let's plug in what we know. Right, so area is 113.1, which equals pi times radius squared. So if we can find the radius, we can get the diameter, because the diameter is equal to 2 times the radius, right? So we need to get the radius, and then we can get the diameter. First thing we need to do, get that r by itself, so we're going to divide by pi. And so, what do we got here? 113.1 divided by pi is pretty close there, so approximately 36. All right, so 36 equals r squared. We don't want r squared, we just want r. So to get rid of the square, we are going to take the square root of both sides. And so r is approximately 6. Going to take that, plug that in right here. Diameter equals 2 times 6. And so the diameter of this circle is going to equal 12, and this was in centimeters. All right. That's pretty easy. That's review. Should have been doing that for years now, right? Since maybe 5th grade, maybe earlier. Somewhere in there. All right. So that part's review. Now let's look at something else. Something that we can do with this, how we can use it. So using the formula for population density. Right? Population density, this is how crowded are people into an area. Are they very, very densely packed like in New York, or are they very spread out like in Montana? Right? Some places have lots of people, some places have little people. And the formula for this, the population density, is equal to the number of people living in the area divided by the area of the land they're living on. All right? So number of people divided by area. And so you'll have it written down as people per square mile, usually. People per city block, you can have it that way too. All right? People per square kilometer, whatever. So let's take a look at this. Example 2. Again, we have an A and a B. So approximately 430,000 people live in a 5-mile radius of a city's town hall. We want to find the population density in people per square mile. So, first our equation. I'm going to abbreviate. Population density equals number of people over area. All right, so I know how many people live here. I don't know the area. They didn't give me that. So let's find the area. Area, let's see, a 5-mile radius. Well, anytime you're looking at radius, you're talking about circles. So we want the area of a circle. So area is going to be pi times 5 squared. Well, that's 25. So area equals 25 pi. And I'm going to leave it like that. Okay, again, save that pi for the end. And so if we leave it like this, I don't have to round it off yet. And the less rounding, the better. So we're going to take that, plug that in. So population density equals the number of people, 430,000, divided by the area, which is 25 pi. All right? And so population density is going to be approximately, now this I'm going to type it in, so 430,000 divided by 25 pi, which is 5,474.9. Okay, so 5,474.9. Now we want this in people per square mile. I can't have 0.9 people, right? It's either a whole person or not a person. We got whole people. So we're going to round this off, and we will say that this is about 5,475 people per square mile. Per square mile. All right, not too bad. All right, so again, we use our area formula because that's going to go into our population density formula. So we need the number divided by the area, number of people. That's going to give us the population density. So that's where we use our area formula there. Okay, we got one more. Question B. We have a region with a 3-mile radius, and it's got a population density of about 6,195 people per square mile. We want to find the number of people who live in the region. Okay, so we know we got this is how crowded it is. We want to know how many people are there. So let's write down a formula again. Let's see, we have population density, which equals number of people divided by the area. Okay, so population density, I already know, that is 6,195. I'm going to plug that in. 6,195 equals the number of people, I don't know that, so I'll put X, over the area, which I also don't know, but I did get this right here, 3-mile radius. So that means I can find the area. Again, we have radius, so we know we're looking at circles. Area of a circle is pi r squared. I'm going to plug in my 3 for the radius. So area is equal to pi times 3 squared. And 3 squared is, of course, 9. So area is equal to 9 pi. And I can take that, plug it in right here. 9 pi. Okay, so we want to get x by itself. So we multiply both sides by 9 pi. And let's see what we get. So it was 6,195 times 9 pi which is 175,159.4. Okay, so we have x is approximately 175,159.4. Again, we can't have 0.4 people. We have the whole people. So we're going to round this, and so we have about 175,159 people. There we go. Population density. Find the area, find the number of people, divide, gets you population density, or take the population density times the number of people, gives you, times the area, gives you the number of people. Not too bad. All right, last thing we are going to look at is the area of a sector. Now, before we can really talk about the area of a sector, we have to know what is a sector, right? All right. A sector is the portion of a circle and the area inside the circle that is between the central arc and its corresponding the central angle and its corresponding arc. So the sector is all of this right here. Looks like a pie piece, right? That is the sector of a circle. Now the area of a sector, to find that, we're basically going to do the exact same thing we did to find the length of the arc. And what that is, if you remember, the length of the arc was the length divided by the length of the entire circle, so the circumference of the entire circle is equal to the measure of the central angle divided by the measure of the angle going all the degrees all around the circle, so 360. So what we have is a proportion. We have the area of the sector over the area of the whole thing, so part over whole, equals the measure of the arc, or the measure of the central angle, because those are the same, right? So the measure of the arc over the degrees of the entire circle, which is 360. Okay, and you can do this for the minor arc. You can do the same thing for the major arc. It doesn't matter. Okay, so what you have is area of the piece over the area of the entire thing equals to the degrees for the piece over the degrees of the entire thing. All right? You can either have this as a proportion and just leave it like that, or you can multiply both sides by pi r squared, so you have area of the sector is equal to the arc over 360 times pi r squared times the area of the entire thing. Either way. Personally, I like to just leave it as the proportion. That way I don't have to worry too much about memorizing extra formulas. Because with the proportion, I can use it to solve all three of these. For the formula, I've got to do rearranging before I solve for the other two. All right? Okay, so let's take a look at this. Where we are. All right, example number 3. Find the areas of the sectors formed by angle UTV. Notice, it says the areas, plural, of the sectors, plural. It wants us to find both of these sectors. We have the sector formed by the minor arc, UV, which is 70 degrees here. And then we also have the sector formed by the major arc, USV, right? So we have two different sectors here. We need to find the whole thing. So we'll start with a small sector because why not? Small sector. So our formula, we have the sector over pi r squared equals the measure of the arc, so arc UV over the entire thing, which is 360. Okay? So now we plug in what we know. The sector, I don't know. I'm going to use x. That's what I'm looking for. Over pi r squared. So we have pi times r, which it tells us is 8 squared, equals the measure of the arc, which is 70 degrees, divided by the angle for the entire thing, which is 360 degrees. Okay? Multiply both sides times pi times 8 squared, so times pi times 8 squared times pi times 8 squared. And so let's see what we get. X equals, take my calculator again, I'm going to leave the pi for the end, so everything except for the pi. So I have 70 degrees over 360 degrees times 8 squared, which is a lovely fraction. So that's not going to be very pretty, so we're just going to go ahead and multiply the whole thing times pi. There we go. 39.095. So that's going to be 39.10 approximately. So 39.10, and our units are inches. We want area, so this is going to be inches squared. All right. Now, let's find the area of the large sector. Large sector, again, our formula is the sector area divided by pi r squared, the area of the entire circle, equals the measure of the related angle, arc, which in this case is arc USV, the entire thing, USV, over the measure of the entire circle, which is always going to be 360. Plug in what we know. Area of the sector, I don't know. I can't use x, I already used x, so we will use y over pi times r, well, it's the same circle, so it's got the same radius, 8 squared, equals the measure, oh, well, let's see, it didn't tell me that, did it? But that's okay, because the measure of the entire circle is 360. I know that to be 70, so I can just subtract them. So 360 minus 70 equals 290 degrees. So 290 degrees over the measure of the entire circle, which is 360 degrees. Again, multiply by that, get it by itself. So y equals, well, 8 squared is 64, so 64 pi times 290 over 360. And I'm going to just type this all straight out, just so we can see it another way. 64 pi times 290 divided by 360, and we get 161.966, so that'll be 967. Okay, so y equals 161.97, and this is, it gets still inches squared. And there's the large sector. All right. So not too bad. Again, it's just proportions. You're using the area of a circle, so we can do this. Let's see here. Example 4. All right. We want to find the area of the circle. Well, that's pi r squared. That's easy enough, except there's no radius. Oh, no. Well, got to do something without using the radius. So what we're going to do is use the area of the sector, because I do know the area of the sector to be 35 meters squared. So let's see what we've got here. We've got sector over the circle equals the measure of the arc, so the measure of arc TU over the entire circle, 360. Plug in what we know. We know the sector to be 35, the circle to be, I don't know, that's going to be my x, equals the measure of the arc, TU is 40 degrees, over these degrees for the entire thing, which is, of course, 360. All right, not too bad. It's just a proportion. Cross multiply and divide. So x is equal to, cross multiply, so 35 times 360 divided by 40 degrees. And so x is going to be approximately, what? 35 times 360 divided by 40, 315. No approximately at all, just exactly 315. 315 what area is meters squared? Huh. So not too bad, right? Pretty simple stuff. Again, we're just using this proportion to find something else, which is why I like to use the proportion, not the formula. Because with the proportion, I don't have to do a whole lot of rearranging. Whereas if I'm looking for using the formula, if I'm using the formula here and I want to solve for pi r squared, then I've got to do some rearranging to get that by itself. Where with the proportion, I don't have to mess with that. All right, so last one here. We want to find, what do we got here? We have a rectangular wall, has an entrance cut into it. So we got this little doorway there. We want to paint the wall to the nearest square foot. What is the area of the region we need to paint? So we have this wall here. We've got a door cut out of it. Obviously, we're not going to paint the empty door because there's nothing there. So we just, excuse me, we just need the area of this wall. How are we going to do that? Well, simple enough. We're going to find the area of the entire thing minus the parts that were cut out of it, right? So we have the wall minus the door. Well, the door is in two different pieces. We're going to take it in two parts because we can't do the area of this little shape here because we don't have formula that. What we're going to do is the area of first the semicircle followed by this part here, which, let's see, that is 16 feet wide, and this is 16 feet tall, so right there is 16. So that's going to be a square, because it's the same size. Okay, so semicircle, and we're also going to subtract out the square. Okay, so for the whole big wall, that is a rectangle, so that is base times height. For the semicircle, well, for a circle, it would be pi times r squared, right? We have just half of a circle, so we're going to cut that in half. So times 1/2. And for the square is side squared, right? So let's start plugging stuff in. For the wall, base, 36. Times the height. Oh, it didn't give me the height. Ah, but over here it did. We have 10 and 16, so this is 26 for the whole thing. So 26 minus 1/2 times pi times r. Well, let's see. We don't have r, but we do have diameter, right? So if the diameter is 16, the radius is going to be 8. So 8 squared minus side squared, so 16 squared. And we're just going to stick this in the calculator, see what it says. Move that over so I can see it. We have 36 times 26 minus 1/2 of pi times 8 squared minus 16 squared, and we get, let's see here, 579.469, so that's going to round up, so 47, except the question says we want it to the nearest square foot, so we're going to round this, and it looks like we're rounding down. So 579 feet squared. There it is. So not too bad. There it is. Area of a circle, area of a sector. Basically all it is, you take the area of your circle, pi r squared, easy enough, y'all been doing that for years. Area of the sector, you put it in a proportion. So the piece that you're looking for over the area of the entire thing equals the degrees of the piece that you're looking for over the degrees of the entire thing. Part over whole. Part over whole, part over whole. All right. population density, number of people, divided by how much area they take up. Right? And there it is. That's all we got. Hopefully you found that useful, and I'll see you next time.